when they come, they see this screen.
Okay, it's done.
Okay, let's start.
Okay.
Good afternoon, everybody. We had some problems, and my name is Marco. I'm from Brazil, and I'm the School of Data Program Manager. I'm going to be your host today in this very exciting Skillshare session. The Skillshare sessions happen every month, and that's when School of Data Fellows can interact with you out there, sharing tips, skills, and starting conversations about interesting topics. Today we have Julio Lopez from Ecuador. He's joining us today to talk about how to use graphs for data exploration. You know, sometimes we need visual cues to understand what we're dealing with in terms of data before we even start the actual analysis. Julio will talk about these important steps and give us tips about them. But before we start, let me introduce Julio properly. Besides being a School of Data Fellow, he just finished a master's degree in Energy and Resource Management at the University College London, the Australian campus. He's also joined Extrayendo Transparencia, which translates to Extracting Transparency, an initiative that promotes the dissemination of citizen-oriented government data to improve the accessibility and use of information from the oil and mining industry in civil society organizations and local governments in Ecuador. And as part of his fellowship, he's interested in promoting open data initiatives in the energy sector in Ecuador and Latin America. You can ask questions anytime using the usual channels, and if you're tweeting, use the hashtag #GraphSkillshare. And now here's Julio.
Hello, everybody. Thanks, Marco. So welcome to the Skillshare today. As Marco mentioned, I will talk about how to use graphs in order to do some data explorations before you start the analysis. So this is like a previous step before you start doing your data analysis with any data set that you're working at. So let's start. I will show the slides now. So as I mentioned, I will talk about using graphs for data exploration. The content of this presentation is the following. First, I will talk about the target audience. Then I will move to explain what it exactly means to explore data using graphs. After this, we will talk about some first steps in order to do this data exploration. I will illustrate after with an example about this. And after this, we will quickly see some examples of what kind of graphs you can use for this. And finally, some checklists and conclusions on this. So to start on the target audience, basically what I'm doing here is to introduce you to what kind of graphs you can use in order to explore your data. So for this, I think people that may be interested are data journalists, any open data enthusiast, students, especially those that are starting doing statistics or a statistical analysis. I think this is a really good way to start exploring your data. Also researchers for different organizations, maybe NGOs, civil society organizations, think tanks, and also my fellows of School of Data. Well, let's start with the meaning of this. So what is exactly exploratory data analysis? In statistics, this is when you start doing your analysis, you usually use approaches. For instance, a basic thing is to do your summary of main statistics. And in this, you analyze the mean, you analyze the distribution, for instance, the trends, the median, or the variance of your data sets, of the data sets that you are working with. But also these normally should be complement with visual methods to do this. So that is what exploratory data analysis basically means, to use graphs in order to explore your data and to start doing the analysis. This is really important because when you're working with any data set, you want to make sure that you understand your data properly, and also that you are doing the right things with the data. Normally, you have to see the properties of your data when you use the summary statistics. but this doesn't give you the whole picture of your data sets. So for instance, a very common thing to do is to make a pivot table and then start work just like playing around your data with this pivot table and see how the ranges of your data, what type of data you have, the different variables of your data set. So this is what you do normally. But with the visually thing is that you want to inspect your data before doing any analysis with graphs. And doing this, you may discover new patterns or associations, or even you can just see that the data is not the right data that you should use to make any to prove any hypothesis or do any analysis. And this will also save you a lot of time before, because if you don't understand properly what are your data saying, later you will have problems, and then the data set won't be that useful in terms of what you want to do. So what do you do to start doing this? So the first steps are, there is a really good link on the School of Data modules, the courses. It's called A Gentle Introduction to Exploring and Understanding Your Data. This is really good because here you can see how to create a table, and with this table, how to start making exploring your data in tables. What I'm going to do is here explain you how to do this graphically, which is the difference with exploring your data in tables. So to do this, where is my, sorry. First, once you have the data set and you collected this, you clean the data. After this, quickly, graphically, you can start doing the data exploration. For huge data sets, normally you can just use like a random sample. This will save you time, and it is as the same as you have the whole data set. In some cases, it is really practical to use the whole data set, because this will show you if there is any missing data or things like this. Also, when doing data exploration, you want to be very quickly. So speed here is really important. For instance, you don't want to have a very nice graphs, because this is just for you. This is not as a visualization that you will show to other people or audiences. This is just for your consumption. Yeah. So why is this important? Let's see why is this important with an example. In the 70s, this was already done for Anscombe's quartet. This example that I will explain basically shows you that graphs maybe are also important in order to make sure that your understanding of the data is right. So Anscombe in the 70s, he published a paper, and it's called Graphical Analysis of Data. And in this example, he uses 4 data sets to show that maybe these data sets may have the same statistics parameters, the same summary statistics, when you're doing, for example, correlations or regressions, which means analyzing the relationship between 2 variables, one independent and one dependent. You normally have the summary statistics. For example, I had the summary statistics of these data sets here. So maybe I will show you this in the Google spreadsheet. Will be easier. So I will change quickly this. So here in this spreadsheet that I will share in the references and in the resources at the end of this presentation, you have the 4 data sets that Anscombe uses for this example. Here, well, what I did was quickly start making some scatter plots, like you can see here. It is really straightforward. You can do this by just selecting the data. For instance, I will do this for the first variable, for the first data set. So you do insert a chart, and then you choose, well, here Google suggest you what to do. This is a scatter plot. And then you customize this, adding the trend line. So the trend line may be linear or so. Here you will have, I will do a linear trend. It's not exponential. This is a linear regression relationship. So you have a y and an x, so the independent and the dependent variable. So as you can see, this is the graph that I made. And this is right. So you can see now how the trend, these dots means the combinations between the y and the x data. And then you can see how's the distribution, the trend of this. So I did this for the 4 data sets. And now you have the visual appearance of all your data sets. This is what Anscombe did in his paper. And he evidenced this. So I would change quickly the screens. So the summary statistics of these 4 data sets that I just graphed are this. All of them have the same mean in terms of the same variance. And even when you do the correlation, I think all of them have the same correlation coefficient, which is 0.8. So these may give you a ground picture of your data sets, because it's not the whole thing. But when you do this graphically, which is the graphs I just made, you can have a look and see what difference is this. For instance, in the same graphs have the same trend, as you can see the lines. But if you see the dots are totally different. For instance, graph 1 has, well, almost all of them follow the same trend. But with graph 3 and 4, it is not the same. We got graph 3, we have an outlier, which is observation that doesn't, well, just change the whole trend. This is more evident in the graph number 4, where all of the observations have a vertical line trend, but because of one of the observations is bigger than the other in terms of the value, it changes totally the trend. So what the summary statistics says are that all of them have the same characteristics or the same properties, but when you do this graphically, it changes completely. So this doing this visually, because you will have another element in your analysis to make sure that your data sets and your understanding of your data sets is right. So this is how this illustrates the importance of this. So let's see what other common graphs we can use. The one that I showed you first was a scatter plot. That's the one I just draw in Google spreadsheets. A scatter plot is basically a graph that you do to see the relationships between 2 variables. In the data, in the example I'm using, which is a hypothetical example, it's not a real life example, but you can see in the scatter plot, you can see the trends. Also, each value, each combination of the values of the 2 variables is graphed as a dot. And in the graph, for example, you can see what exactly means everything, the anatomy of a scatter plot. In the scatter plot, it's important because you can see outliers. An outlier normally is obviously a higher value. It's a value that it's really not following the same trend of the others. I mean, it's not, for instance, it's bigger or it's very small in comparison to the other, or the mean of the data set. And this is important because even if you do this graph and you see outliers, you can quickly go back to the table of your data set and see if there is any error or any mistake in the typing. Probably it may be a period or a comma mistake. So when you do these graphs, you go back to the table or your raw data and make sure that your values are right. Or if it's the case of an outlier, you just have to be aware of this in the analysis later and not to make conclusions on you make conclusions taking into account these elements. So that's the importance on the scatter plot. As I show you in the Google spreadsheet, is really easy to make, and I think this is a really good graph when you're doing regressions or comparing relations between two variables. So what is the correlation? You have the correlation coefficient and the basic statistics like the R square and things like that. So moving a bit, this histogram, which is another type of graph. It's a bar graph that visualizes the distribution of the data. This is really one of the most common graphs that are used to do a statistical analysis, because you have the frequencies in one axis of the graph, and in the other you have the intervals or the time periods. It depends on the type of variables that you're analyzing or the type of data that you have. So let's see if we can do this in a Google spreadsheet, but it will be, you have to do some calculations before. So I will show you this in a Google spreadsheet. So here I made one. So first you have to see what do you have in the, this is a really small data set, so it is just a practical example. You have here the same data sets that I use for the Anscom's example. I mean, they are from the Anscom's example. So you can see here what are the values. Then what you have to do is group them in ranges, which is called classes or something like that. It's called classes in statistics, but it's just a range of the different values of the data you have. So the values I gave for these data sets are, for instance, this means 0 to 4. The next one means 5 to 8. Then the following 9 to 10, and afterwards like that. So these are the ranges I gave. And then you just do this. Once you have the ranges, you use the frequency formula in Google spreadsheets. So it's frequency, and then you have to choose first the data, and then comma, and then you choose the ranges you want to see the frequency of your data in these ranges that you just did. So this is the frequencies for the x2 data, the variable x2. And then once you have this, what you do is just like graph a chart. So you choose select the data, then you go to charts, and then you choose the bar type of charts. And then you have to choose this option, which is use a column as just like the labels. And then you have in this axis, in the y-axis, you have the frequencies. So let's just change quickly the title of this. This is the left. So you have the the frequency. And then in the horizontal or the x-axis, you have the ranges. So these ranges are basically, this one is, as I mentioned, 0 to 4, and this one is 5 to 8, and all of them are like these ranges. So then you have this kind of histogram, sorry. But yeah, in Excel, you can do the same, and then you choose in here the data properties, and then you choose like the 0%, in this space, the 0%. So all of them will merge, and then you will have the classical visualization of a histogram. So that is basically how you do a histogram in Google spreadsheets. This may be like a bit, it's not very difficult, but you have to choose the ranges in advance, and you have to be aware of which ranges you want to analyze. For instance, if it's an age group, you, I don't know, group them if they are kids or adults, something, or groups like this. or if this is like, for example, cities, you have codes or things like that. So you have to be aware of the ranges of that you're grouping your data, and then the frequencies that the frequencies will order depending on your ranges. Or it's a time period, for instance, between years. So that's also a type of range that you can use in your data. Another graph that I just add here are called range bar. So in here, what you're doing is, when you have your data, and in the summary statistics, normally you include the minimum value and the maximum value of your data set. What you're doing here is exactly using these values. So you have the minimum value and the maximum value, and you graph these in order to have a visualization of your minimum and maximum values. So you're comparing the ranges of these values. As you can see here in this graph, you can see how is the anatomy of a range bar. You have the scale in the y-axis, and in the horizontal axis you have the categories, or like the label of your variable. For instance, you have cities here. I don't know, like in Ecuador you have Quito, the capital here. Then you have other cities like Guayaquil, Cuenca, or any other, or in states in the US. I don't know, like or cities in the US, New York, Washington, Miami, LA, or things like that. So you have the minimum and the maximum value, and you can see just quickly what are the differences between them. And if you're analyzing cities or analyzing like specific groups, specific categories, you will quickly have a whole graph that will show you what are the differences in terms of the scale of the values of your different variables or your different categories. So this is this is not complicated, and I think this is really good in terms of give you a whole visualization of the picture of your data. So these are the three graphs that I am explaining today. At the end of the presentation, I have the resources, a list of resources, and in one of these I have the data visualization catalog. This is a really good way to start getting familiar with the different types of graphs or charts that you may have. So I will show you, for instance, this one. In this website, you can have the different charts, as you can see here. So you have this is also, I will show you the box and whisker plot. This is also sometimes really useful when you're analyzing your data. And here you have because here is really, this is a statistics visualization of the percentiles. Like you have your average, and then you have the median, the average, or the median of the average number of the value of your data, in this case a variable, and then you have the other, you have the minimum and the maximum value. So as I mentioned in the others, you have here like the whole properties that we talked before in one graph. But you have to be aware here that you may see how your data is skewed to one direction or any other direction, or if your data is symmetrical, is well distributed or not. These are more common for previously when you do regressions. This is one of the graphs that you use to explore your data before you present your statistics, for instance. Another resource that I want to show you is the in the School of Data website, we have two very good guides on. The first one is how to do a gentle introduction to data exploring, and the other is basic graphs with spreadsheets, how to make a histogram and then scatter plot. So you can easily follow in these guidelines in Excel or Google spreadsheets, and you can just easily make these graphs and make tables like a pivot table that I mentioned before. So those are the graphs that I wanted to show you. Now let's move to what is important when you do this kind of data exploration. You may have some, I don't know if Marco have any question before going to the checklist.
Yeah, I have a couple of questions, but I think we can go to the checklist, and then I'll ask the questions as soon as you finish.
Okay, cool. So let's go to the checklist. What I wanted to do with this checklist is just give you a guideline when you're analyzing your data. So you're exploring your data before starting the proper analysis. You want to make sure that you're understanding your data. That's the whole point of doing this data exploration. So in order to do that, you can ask yourself some questions. The first is if you identify missing values. To do this, a good example is, for instance, go to your scatter plot and see if there is any outlier or is there any points that are not in the graph or something like this. So then you have, you can identify any outlier or any missing value in this graph. Or in the pivot tables that I mentioned, also you can see if there is any missing value there. So then when you're graphing this, making graphs with this or charts with this, you have to make sure that you the graphs are following the right summary. The summary statistics are reflected in the graphs that you're making. And also if you consider doing any correlation between the variables. So for instance, the relationship between two variables, what is the impact of consumption and the household's consumption and the GDP, for instance, or relationships like that. What is the impact of education in income or salaries? You want to see these correlations. So scatterplot may gives you what is how is the relationship graphically, and also here you can see if there is any confounding problem, which I didn't mention before. But this concept of confounding means that when you're analyzing a correlation or a relation between two variables, you may not be taking into account other factors outside this relation. So for instance, I don't know, there is not, I will give you, like, if there are health issues or like people during summer, maybe, I don't know, it may be because of the weather or things like that, but also will maybe because of the behavior or things like that. For instance, ice creams or in kids may have health issues, but also it's not only because of the ice cream, it is because of the weather. So things like that, these relationships that you're not considering, that's what it's confounding in statistics. It's a concept that refers to this, the other elements that you're not taking into account in your relationship analysis. Another useful thing of doing graphs is that when you're doing the ranges, you make sure that the units or the values of your data sets is right. So in the ranges, you see how it is spread in the data is spread in the graph. So you can see the ranges that are make sense or may not sense in the analysis that you're doing. Also, when you're using any subwords, you can see problems in the errors or identifying the variables or miscoding them. So normally a good tip is that when you're doing this data exploration, you also complement this with making your own language for the variables that you're analyzing. So you are familiar with the data set yourself, and then you quickly go through the variables that you're analyzing. So if a name is not common for you, GDP is like, the code may be GDP. But for instance, I don't know, if you have cities, really long names, just short them or use codes for this. So that will give you a sense of your own language when you're analyzing your data set. And yeah, so you will have in the websites I put at the end, if you want to explore other types of graphs, you can see what other types of graphs may be more informative for you depending on the analysis. But I think the 3 graphs that I mentioned before are really the more common and the ones that will give you lots of information of your data. So to conclude this, the first thing is that using graphs for data exploration complements the statistical analysis. So it will give, and I think this is really important because normally we are more, I think a graph or a picture is very powerful in terms of communicate things. So when we do a graph, we are taking these different insights from our data in a graph. So that's important. And then you easily or quickly can see what are the characteristics or the properties of the data set you're analyzing. And also, as I mentioned, plotting the data may give you some information as if there are outliers, if they are confounders, is there missing data, or the relationship or the correlations that you're analyzing is right. So making a graph will give you this information. Once you are familiar with making tables, with calculating an average value, the mean, things like that, then a graph will give you a complement for this analysis. And also, as I mentioned, don't make assumptions when you're doing relationship between 2 variables. Normally, so I've seen some analysis that immediately assumes causality between, for instance, the independent variable and the dependent variable. This is normally not the case. You have to be aware that correlation coefficient that is very significant in terms of statistics. For instance, the confidence intervals are over the 90%. This is not the case. This is not a straightforward causality. You have to be aware that there may be other variables that can have an impact on this. So you want to have another explanations for your conclusions before you go in advance. So when you do graphs, maybe you are trying to analyze different types of variables, and when you graph this in a scatter plot, you can see which one follow the trend, which is not following the trend, or which one is fitting the best in the spreading of the distribution or your data. So things like that may give you other characteristics of your data. And also the last tip or conclusion for me is that in this case, you have to do this quickly because this is not a visualization at the end. This is just for your consumption. It's for your aware of the characteristics of the data that you are working with. So I think those are my advices today. I don't know, Marcos, so you have questions now?
Yeah, I was interested in learning if there are any other tools that you know that can generate those graphics that you suggested, like the histogram, the scatter plot. Do you know of any other tools?
Yes. Yeah, that's a really good question. I didn't include a tool slide here because I think most of these graphs can be draw easily in Excel or Google spreadsheets, but
I think I lost you, Julio. Can you see if there's a problem in your audio? Yeah, I can't hear you. See if your phone is well plugged. No, it's not working. We lost you. Yeah. No, it's okay. Oh, it's okay. I'm gonna ask more questions on Twitter then. I have 2 other questions, which are if there are other graphs that are also useful to diagnose data. So you gave us 3 examples. I was interested to know if there are more and what those graphs are. And my last question, I think it would be, because some people are intimidated by learning statistical skills, right? And what would be your tips for those people that they want to start, but they are a little scared, right? So where to start and tips that, I mean, if you felt kind of intimidated when you started, and what were your strategies to come around it? So those would be my 3 questions. We can wrap up, and because of this technical problem, I can't hear you, and then I imagine other people can't also hear you. And we can answer the questions on Twitter and Facebook and Google+. We'll post the questions there in the slides. All right? I will finish this Skillshare session. Thank you, Julio, for being with us. And I'll see you guys in the next Skillshare session. Yes. Bye.